Hello, everyone. Thank you so much for joining the dialogue today. Please raise your hand if you have learned something new today here at TNW. I see hands all around. I have learned a great deal, and I'm so pleased to join the conversation we're having here in the Future Generations track. I believe we've asked important and challenging questions today about how not only can we marvel at this next generation of technology, but we can acknowledge that it's our responsibility to ensure that we are using technology for the good of all humans, not just for the excitement and the thrill of new opportunities. So thank you for joining, and I invite you to join me now on a journey. It will take us all the way to outer space, but back mostly to Earth, because in my work, we ask how technology from space encourages sustainable development on Earth for everyone. My journey actually begins years ago when I was a high school student and first had the opportunity to learn about NASA's work firsthand. I was nighttime in July 1999, and I had the privilege of watching the launch of the Chandra X-ray telescope late at night, almost midnight, as the sky turned from dark to bright as day, and the vibrations of the engines thrilled all of us. It was then that I decided to become an aerospace engineer. But I was also a bit troubled because I was worried that I'd enter a career that was more focused on the universe than on life on Earth. But I was wrong, it turned out. And I've learned since then that technology from space can play a key role to support life on Earth if we design it to do so. And so now I lead the Space-Enabled Research Group at the MIT Media Lab. Our mission is to advance justice in Earth's complex systems using designs enabled by space. Another way to say that is that we are concerned with using technology from space to support the global goals of sustainable development, as summarized well by the 2030 Agenda. Who here is following the work behind the 2030 Agenda for Sustainable Development? All of you, in some way in your work, can ask how your daily work is affecting one of these goals. The goals are so broad, but they are also the key challenges of our era: to end extreme poverty, to ensure that everyone has access to food and water, and to make sure that basic needs as well as advanced infrastructure are effectively designed for all of us. In my work, I show that technology from space is already being used to address these goals. In fact, there are 6 kinds of space technology that we should all be aware of. Many of us use these technologies in our daily life and don't even notice. But there are those around the world who do not have equal access or equal benefit yet to these technologies. So in my work, I work to reduce the barriers, to make sure that all humans are able to use these technologies as part of their own national and community development. In particular, I want to highlight satellite Earth observation, satellite communications, satellite positioning and timing, as well as microgravity research as part of human spaceflight, technology transfer from space into other sectors, as well as the inspiration that all of us draw from astronomy and space research. Let me give a few examples of how these technologies are already being used around the world to make a difference in sustainable development. One example is an Earth observation, and we can learn from the case of NASA. NASA operates a number of satellites for Earth observation. In fact, there are about 20 satellites. Many of them are taking pictures, but in fact, more are actually measuring key variables on Earth. The examples you see here are satellites that study the atmosphere and the land, as well as what's happening in the ocean. As they orbit, they are all making unique measurements that we can then analyze with Earth science models. And these models show us key aspects of what's happening in our environment so we can better take care of our own planet. Now, it's important to clarify the kinds of information we gain from these satellites. In this example, you see a case where we're taking a direct image of the beautiful island, giving us a picture the same way that our eyes would see it if we were standing about 200 miles off the surface of the Earth. Now, this is one beautiful way to observe the Earth, but if we want more information, we need other kinds of information. Here's an example of looking at another image, and you may be able to guess where this is located if you're familiar with the geography of the United States. It's in farm country, and you're seeing irrigated fields in the state of Kansas. These pictures are one way to see what's happening and how humans are changing the Earth. but there's more to see if we combine mathematical models and science with the data from satellites. This image helps us understand actually a visualization, estimating the temperature of the ocean globally, as well as the way that currents are flowing around the world and spreading energy through the ocean. This kind of information is possible because of many, many images and many data points collected both in space and in the water directly and combined through powerful computer models. Other examples, like this one, show a combination of information from a multitude of satellites. I draw this from NASA's free website that shows a lot of visualizations of satellite data. And it is combined based on measurements taken by satellites from the US and from several other countries working together, including Japan and several countries in Europe. With this kind of information, we now have a wonderful insight into what's happening around the globe. Another case shows actually the breathing of the planet, in the sense that we see the global change of chlorophyll in plants on land as well as in the ocean. All this information we can use in very practical ways. In fact, already there are programs in the United States coordinating with about 25 countries in Africa, and they provide monitoring of areas where we're in danger of either a famine or a drought. And they're able to estimate where we expect to see food security concerns and provide information in advance. And as you see here, local scientists also know how to use this information, and here they are thinking about how to improve the quality of tea farms based on satellite data. So Earth observation is already being used extensively around the world to improve our understanding of the environment and improve decision-making in development. Let's move on to satellite communication. Here's an example where we have great benefit because we can spread information, whether it's a radio broadcast, television, or internet connection, all around the world, including in rural areas. Here you see examples from the country of India that operates a satellite program and operates their own rockets and communication satellites. Here they are enabling an opportunity for someone in a rural area to connect with a specialist through telemedicine. And these are some of the benefits we gain when we connect rural areas to satellite communication. Satellite positioning is really a part of all of us. Many of us are using satellites in our daily life as we find navigation around a city. It's also valuable in fighting disease. In this case, you see someone who is working through a methodical process to spray to reduce the likelihood of mosquito activity that may spread malaria. And for this kind of campaign to work, it's valuable to first identify the locations that are going to be sprayed, map them with satellite-based mapping, and then put this into a computer so everyone can see exactly what's been covered. These kind of applications can save lives, especially in an area where there may not be high-quality maps to start. Let's move on then to the next topic of microgravity research. Here, all I want to say is we can learn about the human body, as well as about plants and materials, and understand how they behave differently when we take away the variable of gravity. Hopefully you recognize this. This is the International Space Station, which is one of the key examples of international cooperation of our era. About 15 countries have collaborated in very close cooperation, both on Earth as well as in space. And over 95 countries have sent some kind of research project to the space station to understand our bodies and plants and manufacturing techniques. Now, this knowledge can actually improve life on Earth because we transfer our findings back to inventions and manufacturing and even healthcare. But the key question we want to ask is, in the future, will we have more opportunity to define the research in microgravity, not just based on traditional space countries, but on the emerging countries around the world, especially in the global south, who are more and more interested in being involved with space. Let's continue on to space spinoffs. By spinoff, I just mean a case where we invent something first for the astronauts, for the space robot, or for the advanced astronomy mission. But later, we realize it would be useful to transfer it from the space application to a system here on Earth. One great example is this water filtration system. It was invented because, well, astronauts only have a limited amount of water on space station. After they drink what they've used, they have wastewater, a little bit of urine mixed in, and it needs to be cleaned so they can drink it again, because they're still waiting for the next shipment of water to arrive. So you can imagine the water filtration systems used on space station are high quality. So the same technique can be used, of course, to filter water on Earth. And in fact, the particular technology inside the space station water filter has already been transferred and is being used around the world to clean water for communities, especially during disasters. Let's continue on to one of my favorite topics of inspiration. I count this as a technology or a category because what we're seeing now is a global rise in interest in training every age to be involved with space. Not only is inspiration coming from space education, but we see more countries getting directly involved with astronomy research and other kinds of space science. And I see that this means development, because the countries are interested in creating their own opportunities to be a part of the space community. I'd love for you to take a guess in your mind about where this location might be. What I'm showing you here is a radio telescope, and it's located in Ghana, which is one of the newest parts of the international project called the Square Kilometer Array. This will be a multinational effort happening both in Africa and Australia, a ground-based telescope collecting radio waves from the universe. It'll help us understand long-held research questions around what's really the makeup of the universe and what happened in the early formation of galaxies. And a number of African countries will be directly involved, helping collect these radio waves, and they'll be combined with advanced computers to help us answer long-term questions. These kinds of opportunities are newly opening up, so countries around the world are more and more involved with space research and engineering. I'd like for you to meet my friend Elika. She is from Venezuela and works in their national satellite program. She is one of the young people who is training and studying as a satellite engineer, and she's already innovating new techniques for how her government designs satellites. This is another friend of mine named Hala. She's from the Sudan, and first worked with a team of students just on their own interest to create a model satellite in their university. They tested it to make sure it could communicate and to see that it had all the parts required to go to space. Later, she earned a fellowship from the United Nations and continued her studies and earned a graduate degree in satellite engineering. People like Elika and like Hala, they believe that space is for everyone and that their countries have a future building satellites to observe their own environment and to help address their own satellite communication needs. What we're seeing is governments around the world also agree that space is a key part of their national development plan. Here's examples from South Africa, from Thailand, and other parts of the world where I've had the privilege to visit and speak to country leaders who are trying to create their initial generation of space activity. Let's give a shout out to Kenya, who we've recently seen the launch of their first national satellite project, built in collaboration with a team in Italy. So countries around the world have traditionally been using data from other national satellites, and they still will, because in fact, every country benefits from the global marketplace for data and services. But it also makes sense for each country to ask, how can we design our own capability and our own knowledge to harness technology to make sure we're using it for the benefit of our own people and not for harm? As we think about this, we can also ask, what is going to change in the space sector in these next few years? I hope some of you are watching because it is an exciting time to be in the space industry. The message I want all of you to know is that no matter what industry you're in, it's going to get easier and easier to use technology from space in your business model and your organization. Some aspects, such as the satellite-based navigation system on our phone, will be easily woven in and you won't even notice you're using it. But other times, it'll make sense for you to think about taking a proactive role to invest in some kind of research using space technology, to harness a novel satellite opportunity, or to partner with an organization in space. So let's ask what's changing in the launch, manufacturing, and services that's going to make it easier for all of you to be involved with space going forward. On one hand, we can think about the engineering of space technology. Traditionally, this is your typical picture of a satellite. It is very high quality. It's built, in this case, to monitor the environment. It has a number of very expensive and very useful science instruments. It takes about a decade to go from the early planning to the design and testing and operations. And you can see it's about the size of a large vehicle. These satellites can cost hundreds of millions of dollars or euros. And of course, they're high quality and very valuable, but they're no longer the only way or the dominant way we build spacecraft. What you're seeing now is a revolution in what we call small satellite engineering. This means that we're asking how we can use much smaller, more affordable satellites to do new missions. They don't really replace the traditional satellites. What they do is give us different ways of thinking about the quality we expect in the spacecraft and the kinds of missions we want to perform. Now, you'll hear a lot of suggestions and business ideas coming from companies around the world to use a large number of these satellites to observe the Earth or to do communication services. And we're still waiting to see what will be the right business combination. But as we consider these traditional large satellites, they still play a role, but we're also seeing a new generation of young engineers learning to build these smaller satellites. Here's an example of elementary school students that together as an entire school built a small satellite that was launched into space by NASA. And I like this example because it just shows that the technology is currently accessible. The complexity is coming down, but the imagination is going up. We have a chance to ask, how will these technologies change our future? Some of the companies you may be watching in the news these days include Planet. They are operating enough small satellites with imagers, taking pictures of everywhere on Earth every day. Now, this is not free data, but it's valuable for business, and you may find it's useful in your business area. We're also seeing companies exchanging how we want to imagine the future of human spaceflight. Sierra Nevada wants to make the next generation of human spaceflight vehicle that lands like a plane. You see companies such as Blue Origin thinking also, and SpaceX, of course, thinking about the next generation of rockets and engine design. All of these are experimenting in a way that lets us ask, what will be the next generation of both government and private activity that will change opportunities and make it easier for you to send an experiment up to microgravity to find out how your technology or your product works in space. These are opportunities that will be cheaper and cheaper as we see increased commercial activity in the space community. So keep an eye on the space news and ask a friend perhaps who has a good idea of how to estimate what's going on in the space community so you can make decisions on how to enter this community. You can celebrate the activities of Rocket Lab, which has recently started their commercial operations, as one of the newest rocket launching companies focused on these small satellites area. In the future, rather than having to go through a specialized space company, your company could have your own satellite launched on a smaller rocket, giving you a unique mission that will be affordable as part of your business opportunities. In my work, I'm most concerned that these benefits don't just come to large companies and those traditionally leading in the space industry. We want to ask how this will also come to those who are traditionally not so involved with space or in communities that have experienced discrimination or some kind of injustice in the past. We expect to see new ways to manufacture in space, and there are those already exploring that even now. And this technology can change the options for what kind of marketplace we see in the space community. I currently lead a research group composed of researchers, graduate students, and undergrads. And our goal is to design initiatives in partnership with community leaders around the world. This means we talk to people in national governments and multilateral development organizations like the United Nations. We also talk to entrepreneurs who work directly in projects for development on the ground. And we bring together these 6 techniques to ask how we are going to design the next generation space applications to ensure that everyone is benefiting from technology from space. My argument is that only when we bring together these 6 areas can we identify exactly the designs we need, because we need to first ask about the humans. And so we start by thinking about design strategies and ensure we understand end user needs. We also keep on our team someone who is a practicing artist. And that allows us to ask, what is the human experience of the challenge we're trying to address? And how do we communicate the technology in a way that everyone can understand? We continue from there to harness social science research that may include history, economics, or anthropology. This allows us to ensure we understand the social context of our work. All of that feeds into an engineering design process. We use computers to do complex system modeling. This just means we're simulating how the world really works using information and math, and it helps us imagine how we can then use new technology to make the kind of future we want. We also build satellites, and I hope you'll follow the news of our work as in the future we propose new designs that will make building satellites more sustainable. Ultimately, we want to use all of this to create the next kind of data that informs decision makers who are pursuing these sustainable development goals. As you can see, And when we use space technology to support development, there's a role for every kind of thinker. Whether you see yourself as a social person thinking about the role and the needs of humans, or you see yourself as a quantitative analyst thinking about how to use high-quality data and big data to understand trends, we come together to ask how we can make sure that technology as advanced as space is really meeting a need on the ground. So I hope you'll consider joining this movement to ensure that we can all be enabled by space, because the development challenges we are facing are vast, but of course we believe, just as we heard earlier, that we are human agents who can bring together our skills and our imagination to ensure we are all space enabled. Thank you so much.
Thank you. Dr. Danielle Wood.
Thank you.